Good morning. Happy Tuesday, everyone. Okay. So, this is a continuation of the last stream. We are picking up in a unit test that is trying to sync a SQLite database from one server to another server. So, we have a server's temp directory and the application database's temp directory. This represents two different machines. We are creating happy DB3 on the server temp directory. We're opening that in SQLite. Rusqlite. Yes, it's a SQLite database. This was just Copilot's mumbo jumbo. It would work for now. We just want some basic 4 kilobyte database on the machine. Now, open could, no, that's a path. I wonder, does connection have, does it have a different method for opening? I want my autocomplete here. Let's go check Rusqlite's documentation. I want to know if it can open a URL. Blob open, close, create collation. Oh, interesting. Open in memory, open with flags and VFS. And flags in this case. Read, open, create. Oh, interesting. Yes, we want this. Ah, the file name can be interpreted as a URI if this flag is set, which could be useful if we want to open it as like with SQLite flags. Maybe we want wall mode, right? Different kinds of journaling. Now, what is the default? What does connection open use for flags? That is equivalent to open create. Oh, open URI, no mutex. I didn't see what this one was. Let's go look at that. No mutex. The new database connection will not use a per connection mutex. Okay. That seems okay. I forgot to start my music. Give me a moment. It helps with all the other little voices in my head. Entertains them while I drive. Oh, going to the wrong place. Let's fix that. Almost there. It's to come out of my headphones, which apparently aren't on. Maybe that's the problem. There it goes. Automatically selected. Whoa, a little loud. Okay. So it looks like we can interpret this open flat, this path as a URI. That means it could be just a string. It could also have full flags in it, right? Or query parameters. This here. No. Oh, I wanted to see that. Where did it go? Here. URI file names. Mode. Where's the journaling mode? No log. Okay. Journal. That's the only reference. I do not believe you. Anyhow, it's not needed. That was just a little bit of a side journey. So we want to create one of these. And then I want to make sure it's like on disk, it's committed to disk. Fascinating. So how do we, I want to see what's in that data, in that directory. So for the moment, let's comment this out and let server tempter equals these things need to be a tempter object. Is there a way to keep a tempter around? Just for testing, right? If you wanted to know and wanted to keep something around, closes and removes the temporary directory. Yes. So as soon as that drops, it's gone. New in. Well, we could do that. Basically, I just want to see like a ls, a listing of that directory. So maybe we just do a, let's close all the tabs. Too many tabs. Close tabs to the right. 28, sure, bye-bye. Read dir. So we could just read the directory and then debug it. Why not? So after we create this, we drop the connection. Here, we will do a let blah equals standard fs reader. And this will be server tempter dot path. Okay, we will read that, then debug it. Okay. So what did we have? Panicked at 6:49. Okay, because the events don't match, which is great. Morning, Nightshade dude. How are you? So it looks like the database was not written to disk. Why would that be? Unless I put it in the wrong directory. It was server tempter, join happy 3. Ah. Wait, that did not work. It did exactly what I asked. Me, I'm okay. Yeah, I'm doing okay. A little sore from yesterday's workout. Been doing some squats lately. Weighted squats. Or maybe this isn't the right way to debug. Blah dot all. Blah is a reader. And what do we do with reader? We can get an iterator. And that iterator gives us... You're still sore from shoveling 5 times between Wednesday and Saturday last week? 18 to 24 inches? Whoa! Oh, man. Yeah, I still gotta get my snowblower running. I don't even want to think about that. All right. Sweet. Or entry and blot, sure. Debug path. Look, thank you, Copilot. It's way too early for that much snow, right? Oh, look, it is there. Okay, so it does exist. Right. So we have a file on disk. Now, the somewhat interesting piece of this is that, let's see, do we even need database names here? I did update some of this so that we wouldn't need things like that. Server data, yes, it's not even being used. So I changed the test server to iterate and respond with the actual names of the databases in the directory. So we do not need this. I'm going to leave it. We might need it for something else. We create that directory. And then what happens? Right, we have this here. What we don't have is, I think where database info is set. Our page size and checksum should be 4K. That's the default for SQLite. So for this test, I'm just leaving it. The checksum, let's rename this to DB pages. I added this function here that gives us a clone of the state in the checksum at the DB checksum dash map. Okay. Now, I believe the checksum is right, so it's no longer a dummy implementation. Name path pages, we get the pages, get the checksum for all of it. Okay. That seems reasonable. So that's working. Now what happens after DB database info? We fetch the database. We start sending data. Oh, interesting. We get the database stream here. And and we send page number 0 with the data of 0, 1, 2, 3 and the checksum. Wow. Okay. This needs to actually do something very similar to what we just looked at up above. We'll go back and look at that again. Okay. We need something like this down below. I'm just tossing it here. We will clean this up. I want to make this work first. Then we will refactor it. Crawl, walk, run here. So we want the server path. This would be, what is it? Server tempter.path. Database name is happy. That cloned. That cloned. Good. Any other happy.db3 in here? database name, DB name. Oh. We have the path. Okay, we have the pages. Great. Now we can get the checksum for the first page in the database. This would be db pages dot page checksum 0. Maybe we should have the number of pages available. Oh, that would be interesting. I believe this would only ever have one page because the size of the database would be tiny. It should fit in one page. But just in case, we should probably iterate over the file, reading in 4 kilobytes of data at a time, and sending page by page. So let's do that. Let's see. Let's open the file, which is dbpath. We could read. We don't want to read to string. This opens the whole file into a vector. It reads the entire contents. Okay, this will work. It should be small enough. Let database contents equal to that. Now we need to know the contents divided by 4K. So database page count is equal to database. I should have used smaller words. Database contents dot length divided by, yes, that's exactly what I want, but it's 409. It's 2 to U32. Yes, that. Oh, these are different. That's a U32 and this is a U size. Okay, database page count. It's not used yet. For page in 0 dot dot database page count. Don't need to pass the data. Let's start equals page times, yeah. That should just be page size. Let's page size equals, thank you. Database contents start to end. Does this need to be a vector? It does. Wow. Way to go, Copilot. Page number we need to pass in. Let's rename that. Oh, interesting. Fine. And we drop the database stream. Dropping the database stream tells the receiving machine that there is no more data. So it would stop writing And then we should be able to tell that the checksums match, all that. And that's the current error we're seeing, is that the checksums do not match. So if we look, we get this assertion here. It's failing, but up above, it's not a database. That's right, because we were sending data 1, 2, 3, 4 as the database contents. So this should go away. DB. Yes. Naming is hard. Oh, checksum has not been calculated yet because I did not call initialize. Oh, look at that. Okay. But I just pulled that code. That means that it's broken in 2 places. Because when we use DB checksums, we do that. Then we need to call initialize. Oh, no, it's right there. It's right there. All right, let's get the backtrace then. Where did that happen? Yep, that's the offending call. Database. Closures. Spot the error. $6.57. Why would that be at 6:57? What is? Am I looking at the wrong one? Oh, it panicked here. But why would that be at 6:57? Checksum has not been calculated yet. Users. This call here. It's closure. Where is this? Maybe here? 587? That's the beginning of our test. And this is the end of our test? 6:57? Huh. Some details are omitted. Well, let's go full. All right, spot 6. Okay, here's the beginning and the end of our unit tests. And then sometime in the middle, hopefully, scheduler. Okay, no. Blocking, pinning. I think it's this here. This is the one we want, but it has no line number. Okay. But we do know that page checksum is only called in, well, that it's called in this file. It's only called in, let's see, one place. Here. So if it is called here, and this thinks that, oh, we didn't even use the page number. And this thinks that the system has not been initialized. Maybe the paths that exist and the one we're asking for are different. So let's debug the one that we're looking for, db path, and does db pages implement debug? It does. But that's not what we want. We want db. Get db. I just want to list the databases. Is this not used? Okay, that's interesting all on its own. Initialize. Does not need to be mutable. Okay. I just want... We can't do this because dash map does not implement debug. Is that right? No, it's not. Okay. I thought I had tried that before. Anyhow. Let's go back to our unit tests. Let's see. Here. Okay. Let's debug those. Let's get rid of backtrace full. As we've seen, that's not very helpful. It pointed at us in a direction, but not to the line number. Because it doesn't implement... Wait, what? Oh, because hash db... Oh, so one of the states does. db state. I put it at the wrong level. Okay. Is this the same? Oh, that's right. SQLite is one based. So the page number starts at 1. We have a none for page 0. Oh, that does make that tricky. Hold on a sec. Grab some water. I will be right back. I'm gonna kick off an ad real quick. I'll be right back. Okay. So we're back. We're back. What do we do with this? Maybe the interface. I don't like having an empty page or an empty entry here. Hit the checksum for the page and return it. We have some unit tests. This should be helpful. We call initialize. We call checksum DBs. Checksum DBs iterates over the databases in a directory. When we add a directory, we prepare and checksum it. Let's check in here. The contents. We move the wall pages into the database. Checksum it. Checksumming the DB. We ask for information about the database. What is the page size? Page count. So here we have this little +1. There it is. SQLite pages are 1 based. So we have a page. We checksum the page. So we should, maybe when asking for this, if somebody asks for 0, we return with an error. or a certain type of panic that says, you know, SQLite pages are one based. Or maybe the first page is just, you know, 0 here. The first page should be the first one, right? Like in position. I don't care if it's called 0 or 1. Okay. So this needs to be, yes, this is correct. It's not referring to the page, it's referring to the max. But this here, let's say if that is 1 smaller, what does this look like? So page now goes from 1 to 0. Previous page checksum. Oh, interesting. What's happening here? It's this here. It's now n minus 1, that page. What do we use this for? This is the previous one. So this could be none. Right now we're doing get unchecked mute. So in this case, we might get a none back. None, some. Hmm. This would, so the way we were doing this before meant that this was safe. It is no longer safe. Because at the moment, well, this would be, so previously this would be 1. Now it's 0. Oh, but 0 exists. 0 exists. Oh, but we're asking for the previous one, which should be page minus 1. Right? We could just say that's a none, right? Wrap this in a match. Special case for 0, page 0. Because there is no previous for page 0. This just initializes it. Match page 0, none. Anything else? Page n. This would be n minus 1. Oh, but it's a sum, isn't it? There we go. Oh, it's an option of an option. No, this, okay. My mistake. The types are different. Oh, one's immutable reference. Does this even work? It does. It's a reference to immutable none, but it's a temporary, but it still works. Why does that work? Okay, so that might be the only plus one we have. Let's check number of pages. That sounds like a count, not an off by one piece. Let's see, any other plus ones? Okay, we'll have to adjust the tests. Interesting. The tests were not off by one. There was 0. Resize. dB. So this changes. All right. A test. Okay. Interesting. Does resize? Debugging here does seem suspect. Was I done? seems related to resize. The others seem okay. So test checksum, test XOR. I think this was just a very simple test. We say, hey, we've got pages of 10. Most of the time when you open a database, you should be able to know how many pages it has. So we allocate early. They all get filled in with nuns. Try pages, try checksum. What does this do? Oh, it gives us the rolling checksum. Yeah, that's a none. We ask for page checksum. No, we are asking it to checksum for page 0. So for checksum page, we want 0 to be a checksum of this data. We make sure that it can support this length. Is this right? Checksums. This is a vector. We resize the vector to make sure that it can hold this page. Checksums.length max. Does this need to be a page plus 1? I think it needs to be a plus 1 here. Okay. Hash the data. We want page 0 because we're doing a subtraction here. We return immutable reference to none. And here we get unchecked mutable. What's my favorite coding language? The right one for the job. Good question, noob gamer. But outside of that, if I just had my choice and I was going to just go build something, I would pick Rust. Oh, I can't get into that right now. I'm going to keep working on this. Thanks, though. Sorry, I'm focusing trying to fix a test. This does seem to be correct now. Okay, and the checksum tests were fine. It was a page resize that failed. Just making sure the tests cover all the cases here. And pages, resize. So let's verify this. What should be happening? We fail on line 200. Oh, interesting. It was this one way down here. Removing 1 with resize. So we go from size of 6 to size of 5. 3, 4, 5. Boom, boom, boom. So adding pages is working. It's when we start to bring them back down that it's failing. So with that in mind, so in this case, the data would have been shifted over by 1. So this might be failing now. Greater than or equal to. Okay. Now, let's look at these numbers here. Because if that was off, oh dear, what happened? Oh 079. Ah, so it's returning the previous one. That means nothing was removed. Okay. So increasing seems to work. Increasing works. Bringing it back down does not. Greater than or equal to number of pages. Oh, what checksum algorithm are we using? I think we're using one off the shelf. We are using CRC32 fast. So we checksum the database pages individually and then XOR them together in order to combine them to represent the entire database. Excuse me. Need some water. So if the length is greater than the number of pages, then we remove stuff. It is failing at this if right now. Great. We're figuring this out. Is our test wrong? Oh, I didn't look at our test very well. So what's happening? We say checksum 0, 1, 2. Right. Now those should be using the very first entry in the vector, second, the third. So at this point we have 3, 4, 5, 6. We validate the checksums. So we currently have 6. The test is wrong. Oh, wait, no. This is the no resize test. So this is an edge check. That's fine. Here we go down 1, and this was failing. So we go to 5. 5 is not greater than or... Oh, checksums.length. Oh, it just needs to be greater than, doesn't it? Because it's equal to the length. Okay. It was equal to the length. Let's see, it's still failing. the same place. Hmm. Now it's still the same. Which could be that man, I love off by one errors, don't you? So drain here might also be off by one. Is there anywhere else that might be doing it? I don't see it. So let's say we have an array 0, 6. So we have something. Stop it, Copilot. Leave me alone, Copilot. Okay. So let's say we have 6 items, right? Because we've checksummed 6 things. 1, 2, 3, 4, 5, 6. Boom, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, that's 7. So num pages here. So let's say we have those 6, and then we say resize to 6. Nothing changes, right? That stays the same. Not worried about that. Let's look at this one. So let's resize to 5. I should remove the last item. So this is our vector in memory. Checksum's length is currently 6. Number of pages, 5. So 5. So if it's greater, great. Removed pages, drain num pages. This should be all pages off the end, starting at num pages. Let's debug that. In this case, we are draining nothing. So the first one, that's expected. All right, so we're truncating the array with the first test, saying, hey, we need this to be such and such. I think this isn't working. So there were, it was created to have space for 10. Right? Page count, 10, boom. Passed in, and then we resize it to 6. So 10 minus 6 is 4. And we removed 5. Oops. Would be pages plus 1. Because we want to drain starting at man. One. Got it. Yep. Once upon a time, there was an engineer streaming on Twitch who fell into an off by one trap. Let's see what he does. I wonder what an off by one trap would look like if it was like a physical thing. What is the physical manifestation of an off by one trap? Yep. Rust doesn't help with logic errors. If your logic's broken, it's broken. Probably falling on a star, ladder, or manhole cover. Oh, on a stair. I like falling on a star, though. You were on the rung, but you were off by one. That's very true. Man, that has happened to me. Yeah, I think the first two are dead on. A stair or ladder, falling off a stair, ladder, or manhole cover. Hmm. Yeah. I have walked. Usually it happens for me when I'm going down. Going down a stair and then you think you've gotten to the bottom, so you take that step out straight instead of going down one more, and then you fall a little. Mm-hmm. Mm-hmm. Okay. Off by one. Let's see. Let's add a little bit more debugging in here. The first thing we will debug is a and self dot a reference to self dot checksums. Just want to see what it looks like. So what do we have? We have A the first time. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why are these all none? Shouldn't this have been... Okay. Here we have 1, 2, 3, 4, 5. Oh, this is our test. This one. There's something going on here. I don't know where. Let's see. This one. Where's this one getting called from? Oh, I remember. Checksum page calls resize. Oh. Yes, resize. So in this case, we only ever increase, which is fine. Okay. Coming back to resize. It's interesting. Who calls this? Let's make sure we are running that one test, which is called pages resize. Does that go before or after? Running one test, great. Okay, now we know we are running just the one test. What is surprising me is that resize is getting called before our AOEU. Move the AOEU up a little. Here we call resize. We're going to mark the beginning of this. Print line. Starting resize. Why do these happen before our resize? I check some. Oh, we resize here. Oh, we go to 20. I missed this at the beginning of this test. Wow. So we create for 10, we resize to 20, we resize to 5. Let's check. So at the end of this, Let's just print out the length. Resizing to num pages. Okay. Resizing to 20. Actual size is 10? That doesn't seem right. But I think it is correct because we don't do anything that increases in here. Resize only makes it smaller. Let's change that. Resizing to 20. Actual size is 20. Great. I don't think that would have caused a bug. Maybe a reduction in performance because it might allocate more, which arguably would be a bug, but not a logic bug. Okay. Resizing to 5. Actual size is 5. Now here's our test. There are only 5 elements in here. 1, 2, 3, 4, 5. Why are there only 5? I thought there were 6 from the test. 0, 1, 2, 3, 4, 5. That's 6 pages. We have add 3. We add 3 more. We validate the checksum of the entire thing. We resize to 6, which should do nothing. But why when we resize to 6? Right, that's where our starting resize is. We have 1, 2, 3, 4, 5, 6 elements, but the last one is empty. Let's look at these numbers. 28110, 28. Checksum page. So that's the last one. That's at the wrong place. The second one is at the first position. Okay, so somewhere in here, we've got in checksum page and off by 1. Checksum, okay. Rolling. Unreachable. We return this. Wait, does that make sense? Wouldn't we save this data? Where is Celsius? Shelf. Okay. It's here. The previous page checksum. What does previous page checksum mean? Because we resized. Save. Hmm. Should this just be n? Huh. Well, it didn't fail. But now, do we not need the match? Okay, that bailed. Oh, cannot find n in this case. This is page. That's correct. Okay. This doesn't seem to be the previous page. Oh, oh my goodness. It's not the previous one in sequence of order. Like when we're at the sixth item, this isn't referring to the fifth item. This is referring to the previous value in the sixth item when we are updating the sixth item. Okay, yep. Yeah. All right. Let's fix this for our future self. Previous value, previous checksum value. Value before update. It's not even how we're using it. Here, we're just getting the page the page to update. Maybe we just call it that. This reads much better. Okay. Okay, let's clean up the checksumming. Find in folder. TBG. No results. Great. Now let's go to our previous tests. Data plane. And the test pass. Wow. Wow. Okay. So let's go see what those tests were, shall we? Data plane, DB. So we sent back the pages for the database with now the correct page checksum, because the first page is in the zeroth slot. We're not leaking through SQLite's one base system. We drop it, we check this, and that matches. Oh, that's great. So basically what this means is that a download database works. Where is it? Fetch database? No, up here. Download database. So this code has been tested. We open the file, write data to the file, so we wait for data to be streamed to us. We go to a specific place on disk. We write it. We checksum each page as it's being written to disk. Uh-oh, what's going on here? Unused result. Okay, we should fix that. What is the value of the result, though? An IO result. Oh, we need to simply bail on that. But I think it also returns us the number of bytes written. Total number of bytes that were copied from reader to writer is returned. So this should be the page size. Oh. Our page size called here. Page size. DB seek error. Let's create a new one. DB write error, maybe. DB write page error. Perfect. We'll use that one. Let's do a format, and we will say what does it not like about this? Where's our error? Expected one argument, found two. For what? Here, new. New takes two. 1, 2. Format is this here is wrong. Did Copilot do that to me? Okay. Let's make sure that still works. Beautiful. Okay, we have done it. Except, what are we doing with hasher? Validate. Validate checksum. Oh, we get unit back? This is just unit? No, we don't need that. Okay, so a lot happened. We've changed DB checksum. We updated our unit test. unit test now works. It's very, very involved in testing this code from about line 600 to 670. Oh, wait, no, it's even before that because all of this code above the unit test supports it. So from, goodness, 387 to 670, almost 300 lines of code just to test that one function. But it's good. Now we know it works. The next piece that would be tested. Good morning. Happy Tuesday. And the mic I'm using is an Audio-Technica 2035. So the next part of the stream, man, my voice a little gravelly. I should really pour some tea. Do we have the DB locally? So, does database exist? We've finished that. Download database. That is now done. The next piece would be to have a database locally, then update it on the server so that there is a difference between them. And then we update the pages that are different, or rather, that's interesting too. We could just detect that the pages are different and update them. And then stream from a particular version. But I think I want to do this in more of a sequential way. So, to restate, we'll have a database on both the server and the client. The clients will be out of sync by a couple changes. The server will need to send the changes to the client when it says, this is my checksum, please send me data. It will send the mutations from that version to the new version. And then we validate it. After that, we stream the database updates and it stays up to date. So that's next time. I got to get going. And I got to let the dog out, apparently. Let's see. Let's figure out who we shall raid this morning. Who is streaming? Oh, fun. Brooke is streaming. Let's raid Brooke. All right, y'all. Have a great Tuesday. Till next time. Bye-bye. All right, raid incoming in 3, 2, 1. Here we go.